So the synthetic division should be a review. We did it earlier when we did polynomial long division. We also did some synthetic division. We're going to be focusing only on the synthetic division and specifically with the theorems that it applies to. Synthetic division is really important for a lot of higher level algebra. It ties really closely into what we call the fundamental theorem of algebra, and there's a lot of stuff that's related to it. So using the synthetic division allows us to focus on the theorems and less on the math, because it is a shortcut for our division without having to do the long division. So when we set up our synthetic division, who remembers what goes in that box? -3. Where'd you get that -3 from? From the +3. More specifically, if we take our divisor and we set it equal to 0, what does x equal? -3. We set our divisor equal to 0, we solve, we get -3, that's where that number comes from. Alright, what's going to come next? Yep. 2, 13, 30, and 25. So we just get rid of the variables, get rid of the exponents. Focus on the coefficients and our constant. Alright? Step 1. Always bring down the first number. That's the most common mistake I'll see in synthetic division, is that first step. You don't bring it down. They bring it down and then add it. You just got to bring down the first number. Okay? Second step. Yep. Everything in this row will be multiplied by -3 to get the next number in the row above it. So, what is -3 times 2? -6. Everything in this row will be added to get what's in the bottom, underneath it. So 13 plus -6. Good. And repeat. What's next? Multiply to get -21. Add to get 9. Multiply to get -27. Add to get -2. So now we got to fill in our quotient. So we've got all of our coefficients and constants and remainder. So we need to fill in our variables and exponents. So this is going to become a 2x to what power? Squared. We always drop that leading one by one because we're dividing by x. So 2x squared plus 7 what? X plus what? 9. And then does anyone remember how we write our remainder? -2 over x plus 3. You could also write that as plus and then -2 over x plus 3. Either one is fine.
So why is it all x squared?
So if you look at your leading coefficient, or your leading term, here, here, what is 2x to the third divided by x? 2x squared. Make sense? Okay. Comments? Okay. Let's do it again. What goes in the box? Okay. What comes next? 0. You guys are smart. Why do I have a 0 there? I'm missing my a squared term. I'm missing the a squared, so I need to have the placeholder 0. All right. After the 0, -2, and then 1. Okay. So, yes.
On the last one.
Yep.
It's -2 is the remainder, like.
The
So
remainder.
it should be 0 if it would be no remainder on the last one.
If we ended up with a 0, we would have no remainder. Yep. Okay. Step 1. Bring down the 3. Then. Good. Multiply to get -6. Add it to get -6. To get 12. To get times to get -20. Add to get 1. So I'm going to have 3 what? Good. Keep going.
minus 6.
Minus 6 plus 10
Plus 1.
plus 1 over a plus 2. Go ahead and try the next one on your own. Alright, make sure you don't forget that placeholder 0. Step 1. So bring down the negative 4. What is the 0 for? So when I answer this question, what's the 0 for?
Because
There's no x term. There's no x for the first. Bring down the negative 4. Now what?
then you do that times 2.
Okay.
Then you get like 7.
Yep.
You do that times 2.
Uh-huh.
Then you get like 4.
Uh-huh.
And that gives you 8. Right?
Uh-huh.
Then you do that times 2. You get like 16. Then you get 14. Then you get 24. So you get negative.
Nope, not 24.
28. Sorry. You get 28.
So negative 4x to what power? 4 minus minus
X is 7. So can you make that out?
you can't, that's it. If you can break that down, something went wrong. Alright, so now what we're going to do is we're going to apply this to some theorems. So we're going to start today with the remainder theorem. So what this states is we have a polynomial divided by a monomial where we can do synthetic division. So the fact that we can do synthetic division, I have a linear binomial with no leading coefficient. So this says, hey, I can do synthetic division. If we can do synthetic division, then the remainder is equal to if we had plugged in that value for our function. So I have this polynomial and I want to use synthetic division to find f of negative 2. If I wasn't using synthetic division, what would I do with this negative 2 in order to solve? I would plug it in for x. Here, here, and here, and then I would evaluate. Okay? Synthetic division gives us a faster, more reliable method for evaluating when synthetic division was an option. So we still are going to take away all the variables and the exponents. Okay? But now, what we put in the box is still going to be negative 2. there's not going to be a sign change. Remember when we were doing our division, if I had x plus 3, I set it equal to 0, I get x equals negative 3. Here, they've already told us what x equals. X is negative 2. As a result, if I wanted to go backwards, what I'm doing is I'm taking this polynomial and I'm dividing it by x plus 2. That's what this synthetic division is showing. I'm dividing by x plus 2. That's why I have a minus 2 for the synthetic division. So these are going to match. These are going to match. Other than that, we just follow our synthetic division. Bring down the 1, multiply, add, multiply, right? Yep. Add, multiply, add. Now, using some context clues, if I'm dealing with the remainder theorem, what part of this line do I want to focus on? The remainder, negative 45. That's the only thing I care about here. So we did synthetic division. We found f of negative 2. F of negative 2 equals negative 45. Be the same as if I had plugged negative 2 in for x and then spent the time to solve all this. Now, the inevitable question that's in probably several minds is, why do I have to do synthetic division when I could just plug it in and solve? 3 reasons. The first reason is because I said so. Second reason is this is generally a faster method for finding the solution. Okay? 9 times out of 10, I can do synthetic division faster than you can plug it into your calculator and get the right answer. Third reason is this is more reliable than plugging it in. Because if your x value is a negative, you mess up one parenthesis, your whole answer is wrong. So 9 times out of 10, I can faster and more reliably do the synthetic division to get that value than plugging it into your calculator. Especially as our polynomials get longer. If I have a 5th degree or a 6th degree, and you're asked to evaluate, if you plug it in, you are taking way too much time to get that answer, and you're probably going to get it wrong. Okay? If you do get it right, then you spent way too much time solving it. Synthetic division is much faster and much more reliable because we use that information for something else. Okay? So we're going to add in some steps to this. The remainder theorem is not just there for funsies. It's because we use it in some other processes later on. And you want to spend the time doing the later steps, not trying to figure out if it works the way that you want. So, remainder theorem, synthetic division. To evaluate, we look for the remainder. That gives us our solution, negative 45. Okay? Questions on that? All right. Now, similar idea. We want to use synthetic division to decide whether or not 2 is a 0 of that function. So we're doing the same thing with remainder theorem. This applies really closely to remainder theorem, except we're looking for a very specific remainder. Any guesses on what that remainder should be? If I'm looking for a 0? 0. We're looking for a remainder of 0. Okay? So I want to see if synthetic division, if 2 will give me a remainder of 0. 3, negative 11, 17, negative 14. Bring it down, multiply, bring it down, multiply, bring it down, multiply, bring it down. I have a remainder of 0. So that means that this value, which is this value, is a 0 of my polynomial. So 2 is a 0, also known as a solution. And we're going to expand on this more on Wednesday with why that's important. But 2 is a 0 or a solution to that polynomial. Go ahead and do the last one. Alright. Step one.
Bring down the 1.
Now what? 4. Keep going.
-4. 17.
Definitely not a 0. -4 is not a solution. Okay? Quick question. What does f of -4 equal? 285. Different question. Just side thought. Keep you on your toes. Questions, comments, concerns, queries, conundrums? What are you feeling? Okay? Good? Fantastic? I can tell by your enthusiasm.